Good evening, ladies and gentlemen, and welcome to Astronomy Toronto. My name is Randy Attwood, and I'm the president of the Toronto Centre of the Royal Astronomical Society of Canada. Astronomy Toronto is seen here on Rogers on the last Wednesday of every month at 8 o'clock, where we look at different topics of current events in astronomy and also what amateur astronomers are doing here in Toronto and across Canada. Tonight, we're going to be looking at the moons of our solar system. We learned quite a lot of things about the moons in our solar system in the last 5 years. And with me again tonight, for I guess the third time in Astronomy Toronto, is Paul Deans from the McLaughlin Planetarium, who's an expert on the solar system and is going to be telling us a bit about the moons tonight. Thanks again, Paul, for coming.
My pleasure.
Well, maybe we should start out. What is a moon, Paul? What is the definition of the word moon?
Well, first, to back it off a bit, I guess, a planet is a body in orbit around the sun. A moon is a body in orbit around a planet. And I guess, really, that's the quickest definition of a moon.
Well, how have we learned so much, say, in the last 5 years about all the different moons?
Mainly through unmanned exploration, sending spacecraft off into the solar system, to Jupiter, to Saturn, to Mars, and photographing these objects. And also by sending unmanned craft and people to our moon to get some first-hand information.
Well, I guess when we're talking moon, our moon is the capital M moon, while all the other moons will be have their own names.
That's right, that's right. But I guess since the beginning of time, people have just looked up and called it the moon for the body that goes in orbit around the Earth.
Well, what do we know now about our moon?
Well, thanks mainly to missions to the moon, the Apollo missions to the moon, we have a great wealth of knowledge from both on-site exploration and from the rocks that have been brought back by the astronauts, some 800 kilograms of rocks, I believe. And if we have a look on videotape at just some of the activities on the moon, the astronauts, while they were there, were bouncing around on the surface, collecting rocks, sampling, setting up their science stations, so that even when the astronauts left the moon, we could still get signals back to the Earth to study what has been going on. And although the activities took place during 1969 to 1972, a lot of the information continued on.
A lot of the rocks that they brought back, I guess, had already been sampled by unmanned spacecraft. They sent a few to land on the moon and sort of take sniffs and samples, but
yes,
they hadn't brought any back, had they?
No. After the Apollo missions, the Russians developed some nice little unmanned craft that actually took some samples and brought them back to the Soviet Union. But I guess the main thing, the main way we know about our moon is thanks to the Apollo missions to the moon. And we have a couple of short film clips, tapes of the astronauts back now over 10 years ago as they studied the lunar surface. It depends, really, our knowledge, even of the most remote moons, on comparing the photos of these distant moons to the stuff on our moon, photos of our moon, and the results from the Apollo studies.
Well, are the samples that they brought back that different from our Earth, or how do they compare to, say, the meteorites?
The lunar rocks are fairly different. In the main reason being is that they're old. They have managed to stay there for 3.5 to 4 billion years, whereas most of the rocks on the Earth are very new. The old ones have been weathered away and wiped out by erosion. So what the astronauts have been picking up is the very old stuff from back in the distant past.
And the meteorites, of course, are the things that have come down to Earth through the atmosphere. Are they as old as the moon rocks?
In some cases, yes. And the interesting thing is astronomers now think they've actually found a piece of the moon that came down, was torn off the moon by perhaps a large impact, orbited the Earth, and landed on the Earth. They found this strange-looking rock in Antarctica, and by comparing its chemistry to the chemistry of the rocks collected by the Apollo astronauts, they've deduced that, indeed, it was from the moon.
Okay, we've got a bit of videotape here of what it looked like here on Earth as the TV came back from the moon, and oh, there's an astronaut juggling a rock there. I was so impressed from all the pictures of the moon, how desolate it was, but also all the sand. One of the astronauts who came back said that the sand seemed to get in all of the mechanisms, and after a while, things just began to slow down with the grinding till all the mechanisms stopped. And here we can see certainly a view of the gravity as he throws a bit of foil, and well, 1/6 gravity. I guess it was quite a fun
yes,
fun
you
time.
can just bounce around very easily despite wearing a heavy spacesuit. A lot of the upper layer of the moon, the very thin, dusty region that they're busy kicking around, was caused by constant bombardment. The moon is continually being hit by small meteors, and this churns up the surface, if you like, and as a result, the dust got everywhere, literally.
Certainly the sampling was difficult in those cumbersome suits, as we see here an astronaut having a bit of trouble picking up a bag, which falling all over the place would be kind of difficult.
Yes, despite the low gravity, the spacesuit is still very, very awkward.
Yeah, certainly all the dust, as we're saying. Well, 12 astronauts. Trivia question for you tonight. How many astronauts walked on the moon? 12 astronauts walked on the moon.
That's right.
And we learned a lot more about the moon. Our first stepping point to going out to all the others.
One of the big things that astronomers wanted to know was a method of dating things. We knew that the moon was old, we didn't know how old. So the astronauts wandered around on the lunar surface. They were in the flat Mare regions. They went to the edge of the rough highland areas, collecting rocks from different spots on the moon, bringing them back to Earth to analyze them for ages. Because one of the big questions in the solar system is how old are things, beyond the fact that we assume they're 4.5 billion years old, but also what sequence things happened from the formation of the solar system on down. The only way to do that is, of course, to have some dates. But you can't do that except by collecting the rocks and really bringing them back to Earth for analysis. The moon is the only place that we could do that. Now, the first slide that we have just shows a general view of the moon. The dark lunar seas, the bright highland areas. It was always assumed that the bright highlands were older, the dark lunar seas were younger. Nobody knew how much older, how much younger, even specific dates, 3 billion, 3.5 billion, nobody really knew. So by going to the moon and picking up rocks from these different areas, they could finally get some dating techniques down. The next slide, which is of the highland areas, shows that the very, very old areas turn out to be the rugged regions. And these, most astronomers think, are the primeval areas of the moon, 4.3 to 4.6 billion years old. This by dating of the rocks that were brought back. And as you can see, it is a very, very rugged place. Now, you compare that sort of view to the next slide, which is the floodplain area, which is very smooth and doesn't have many craters. You can see one huge floodplain. It's got a few small craters in it. That turns out to be very young. So what was deduced is that the more craters you have, the older the site is. And if you have something such as a floodplain that is very smooth with very few craters on it, then the plain was flooded later on in the solar system's life.
Flooded by what?
In most cases lava, it seems, either from volcanoes on some of the moons or from simply impacts that gouged down into the moon and forced lava from the interior up. So the relative ages that they got from looking at the moon were about 4 to 4.5 billion years for the rough highlands and about 3.5 billion years for the floodplains. So by counting craters then on the moon and comparing that to what we know are the ages, astronomers then proceed out into the solar system and busily count craters to try and get ages of all sorts of different things.
If I stop you for a minute and ask, where are all the craters on Earth then? Does it mean that the Earth isn't as young or isn't as old as the moon?
Actually, it does mean that the Earth isn't really as old. At least the surface isn't as old. And that's because a lot of the craters have been worn away through erosion. So the only craters that we have are the very young ones that were formed within the last few million years at the most, which in geological terms is only yesterday. Now, some of the problems with trying to date things in the solar system is, of course, you need solid surfaces to work with. And this is why astronomers were particularly interested in the moons of Jupiter and the moons of Saturn, because those two planets, gas giants, we don't have a surface. In the case of Venus, it's hard to say because Venus has no moon, as it turns out. And Mercury also has no moon, but fortunately for us, in the case of Mercury, we can see lots of craters. You can do the crater counting on the surface of Mercury anyway. And then going out, Mercury, Venus, Earth, the first moon that we have, then Mars, and we finally come to a world with a couple of different moons on it. Just two little moons on Mars, and the next slide shows these two objects. Deimos is the smaller of the moons on the left. Phobos is the larger one, only about 25 kilometers across or so. The biggest one, smallest one, about 11 kilometers.
So all moons aren't round?
No, I'm afraid they're not. They are jagged in spots, but you see, even on these tiny little objects, there are craters, some of them fairly large. Now, the interesting thing about Phobos and Deimos is that astronomers think that they're captured asteroids. So really, when we're looking at these two moons of Mars, we may be looking at a lot of the asteroids in the asteroid belt, which is the region between Mars and Jupiter. The next slide that we have is a close-up of Deimos, the smaller moon. And this is quite amazing. It's a little hard to see what's going on. The surface looks very smooth. And the reason it's hard to get a feel for this is the smallest objects are only 3 meters across. So the very tiny craters are 10 meters or so. The biggest objects there are probably only about 20 meters across. The astronauts on the moon discovered lots of small craters, and it's obvious that on Deimos, at least, the same thing is happening.
And even and if you were walking on Deimos, if you got up a pretty good run, could you even jump off the moon because it's so small?
I suppose, yes. Its gravity is very, very light. And if you took a great running leap, you could be your own satellite around Mars.
Pitch a softball into orbit.
These two little moons of Mars, as I mentioned, are interesting because of the fact that we think that they are captured asteroids. And the suspicion is that the rest of the rocks in the asteroid belt are probably very similar. One of the proposals, I guess long range, is for NASA to send a space mission to a couple of the asteroids, just to see how they compare with Phobos and Deimos. So really, the first true moons that you get are beyond Mars, beyond the asteroid belt, when you come to Jupiter.
And Jupiter has countless moons, as we know. It used to be, we thought there were 10 or 12, and now as you send more spacecraft out, you get 20 moons.
That's right. Up at the moment, which I think is the best way to put it, Jupiter has 17 known moons. 4 very large ones and 13 or so small 10 to 50 kilometer diameter sized bodies. And when I say large, I do mean large. 3 of the 4 of the moons of Jupiter are bigger than our own moon, and one, the moon called Ganymede, has the title of the largest moon in the solar system. Now, one way is, as we mentioned earlier, to study these things, in fact, the only way that we have now, is to send unmanned spacecraft out to these objects to photograph them.
Why can't we photograph them from Earth? I think a lot of people may not really understand why that is.
Well, you can photograph them from Earth, that is true. But because they're so small and so far away, they appear, even in the largest of telescopes, as only tiny dots of light. So that the only way you could do it from Earth would be to have a very large telescope up in space. Since that's unfeasible for a super-sized telescope, the easiest and the cheapest way is to simply pile a couple of little telescopes with cameras onto a spacecraft and send the spacecraft off to have a look at these almost planet-sized bodies, really.
Well, the Voyager spacecraft, the 2 Voyager spacecraft, both did a spectacular job of sending us back really the first close-up pictures of the Galilean moons. And I think we have a videotape of the Voyager spacecraft.
Yes, the Voyager 2 craft. This video is a simulation of what Voyager 2 saw as it approached the Jupiter system, slipping by all of the moons and a little bit of a look at Jupiter itself. And what you see, the artistry in the video, is the result of the Voyager 1 flyby as well, because the artists who used computers to generate this scene based a lot of their work on the Voyager 1 photographs of the 4 main moons of Jupiter. So they knew very well what Voyager 2 was looking for as the spacecraft approached. So they put together this computer simulated video to show Voyager 2 at the moons of Jupiter.
And this took place in July 1979?
1979.
And when they come up, you'll see the Voyager spacecraft just zooming by these moons and making very quick movements. But the actual flyby took a few days, didn't it?
Yes, it did. It went through over the course of about 2 to 2.5 days for these 4 inner moons. And there you see Voyager speeding in towards Jupiter and its moons. The spacecraft itself encountered a couple of moons first, then went on, flew past Jupiter itself, and then had an encounter with a couple of other moons. First moon that it ran into was Callisto, which, as you can see, a very heavily cratered object. Got quite close and took some marvelous close-up views of this particular moon. It then continued on. Remember, Callisto happens to be the furthest out of these 4 bodies, so it's speeding in towards Jupiter itself.
Might mention that the Galilean moons were named after a man 370 years ago.
That's right.
Galileo, who saw them through a very small telescope.
Yes, although he was among the first to use a telescope for astronomy back in 1610, he was the first to look and see 4 tiny little dots of light that moved from one side of Jupiter to the other. And although eventually they have their names, such as this one, Ganymede, that's the largest moon in the solar system, the 4 of them as a class are often just nicknamed the Galilean satellites. Voyager flying past Europa, the smallest of the 4 at a mere 3,000 kilometers in diameter, which is still a good size for one of these little moons. Voyager, of course, also looked at Jupiter itself, and one of the things that it studied is lightning bolts in the upper atmosphere that we see simulated here. The moon, probably of greatest interest, a moon called Io. The interest is there because it has volcanoes on its surface, not normal Earth-like volcanoes, but volcanoes spewing sulfur out and recovering the surface.
No one really expected to find volcanoes, did they?
No, that was quite a shock, actually. One of many unexpected discoveries that you tend to get when you take a little spacecraft and send it off to the middle of nowhere. Actually, some initial feelings back in the mid-1970s were that sending the spacecraft to Jupiter and Saturn was a good thing to do, but looking at the moons was going to be a waste of time because they were just going to be dirty little snowballs out there with not much to see on them. And fortunately, that view didn't become the philosophy of the mission. And both at Jupiter and at Saturn, the Voyager spacecraft spent a lot of time looking at the moons. Now, we have several different slides sort of in summary of the moons of Jupiter. That, again, I must mention, was computer simulation. And the first slide that we have, which is of Callisto, is a general view. You can see it's very, very heavily cratered. The thing with Callisto happens to be it's very, very icy. And in the next slide, you see the result of having a very icy surface. There was a large impact that forced rock and ice out, but the ice sort of slumped down, and so if you were standing on that surface, it would be incredibly smooth. Moving in towards Jupiter, the next slide is of Ganymede. It is a world that is half rock, half ice. I think it stands out quite well, dark areas for rock, the brighter areas for the icy surfaces, and here you see a lot of cratering. The next slide, a close-up view, shows the same thing, a very heavy cratering on Ganymede. You can see almost, if you could imagine the white areas being ice, a very strange mixture of ice and rock on this particular world. Again, Ganymede holds the title of largest moon in the solar system. The 2 inner moons are even stranger still. The next slide, which is of Europa, shows an almost featureless blob with a few little lines, and for a while everybody thought they'd finally found the mythical canals that were supposed to be on Mars. The next slide shows a close-up view of Europa. and you get what look like grooves or indentations. It turns out that they're really just cracks in a moon-wide sheet of ice. The whole moon seems to be covered by ice. Perhaps underneath that ice might be an ocean of liquid water.
Now that was the moon that lately they were saying that there could be life.
Yes, yes. This is the latest speculation.
How much do they really know about that? Is that just pure speculation, or do they have any facts? Like,
unfortunately, to a large degree, I'm afraid, I think it is a lot of great hand-waving. You have the two missions to go on. One of the things that really started this was the discovery of what looked like a little geyser of water coming out and refreezing on the surface. They know the density, they know there's got to be a rocky core in the center, they know there's obviously an ice shell, and the thought is possibly there's in between, there is an ocean of water. The moon with all the activity was the moon known as Io, and the first slide that we have of Io shows a very strangely colored object. It's red and white and caused a lot of head scratching. Astronomers looked, saw no craters, which caused much confusion. The next slide, which is a close-up of one particular section, shows that what looks like craters are actually volcanic vents, or the mouths of volcanoes. And if you look carefully, you can see running down from the top of the image, for instance, looks like lava flows, which is very hard to believe, as being a small moon, much smaller than the Earth. But it turns out that indeed there's a lot of activity. The next slide shows an actual eruption of a volcano captured by one of Voyager's cameras. It's that strange little blob, if you like, in the upper left-hand corner of the limb of Io. And the next slide is a computer enhancement of that small section, showing a straight column in the center and then a lot of material flowing away out in all directions. It turns out that the surface of Io completely recovers itself about every million years, which is why it turns out there are no craters on that particular object.
and as far as we know, it's the only satellite or moon in our solar system, other than the Earth, to have to be that active, to have volcanoes.
Yes, yes, it appears that there's certainly no other moon with that sort of activity on it.
Well, before we go on to the next planet, Saturn and its moons, I'd like to remind you that we are coming to you live tonight from our studios down here on Adelaide Street. And if you have any questions about the moons of the solar system that you'd like to pose tonight, we ask you to call at 870-9113, and hopefully we'll be able to answer them for you. And my favorite planet is Saturn. And when the two Voyager spacecraft went by Saturn, they got spectacular pictures of the rings, but also they were very surprised by the moons of Saturn.
Yes. I think it's everybody's favorite planet, mainly because of those rings around it. Saturn especially, it was thought that the moons would be little ice balls and nothing more. But again, fortunately, the cameras were trained on the different moons. Saturn has got a much wider range of moons. Jupiter's got the 4 big ones and 13 small ones. Saturn itself has got one huge one, Titan, which turns out to have an atmosphere. It's got 8 medium-sized moons in the range of 400 to 1,200 kilometers in diameter, and it's got bundles and bundles of little wee tiny moons all over the place. The current count is up to around 22 plus maybe 2 more, and they're still going. As astronomers look back at all of the photos that came back, I suspect they will probably find even more of the moons. Now, once again, for the moons of Saturn, just to be consistent, we'll go from the very outside in towards the center. The first slide is of a moon called Hyperion, which as soon as it appeared was nicknamed the hockey puck moon, because that's exactly what it looked like. These 3 views are of 3 different angles, and if you imagine a great hockey puck hanging up there in space, the one on the far left is the hockey puck edge on, and the one on the right is the hockey puck face on. And the next slide shows Hyperion in color, a close-up view. It's a very strangely shaped moon, and one of the only ways that it could get that way is through collision or impacting. The next slide is of another strange moon called Iapetus. Those viewers who might have read Arthur C. Clarke's 2001 might remember that this is the moon on which he put his Stargate. And the reason that he did that is because part of Iapetus is very bright, as you can see, part of it very dim. And the dim regions are lower left, upper right And there's still a lot of discussion as to why it's so bright on one hemisphere, so dark on another. Continuing to move in, the next view is of Titan, and this looks incredibly boring because all you're seeing are clouds, and that's it. No surface features at all. Top half dark clouds, bottom half light clouds. What else can you say? And neither spacecraft saw the surface of Titan. That is still a great mystery. However, the other moons, we've got lots of surface. The next slide is of a moon called Rhea, loaded with craters. And at this point, astronomers started to wonder about their ideas of dating using crater counts, because Rhea was so heavily cratered. Then they go on and look at another moon. The next slide is of Dione, and that is disgustingly cratered as well. One of the things you can see that caused much puzzlement from the top down, you can see little lines that close-up views show are actually fractures in the moon. So it looks like the moon has been almost split. If we go in a little closer, the next slide is a moon called Tethys. Looks sort of vaguely like a huge navel orange with all of its strange bumps all over. It too, very heavily cratered, but it happens to have one massive crater, about 1,200 kilometers in diameter, which caused much head scratching. Continuing in, one of my favorite moons around Saturn is a moon called Enceladus, which is the next slide. This is, it's very hard to see here what is going on. If you compare this to the next slide, which is Enceladus in high contrast, computer enhanced. And you can see down in the lower regions, very heavily cratered, in the upper regions, very smooth, and what looks sort of like a tongue of something heading down. It appears that something on the surface has changed very, very recently. And continuing in, the next slide is of the moon that was nicknamed the Death Star moon because of that huge crater in the upper right, which is about a third the diameter of Mimas. And again, the suspicion is that body was fractured by that huge impact and almost split apart. And sort of as a final look at the moons here, we have a little family portrait of the little moons that float in orbit just outside the ring, some of them. Also, some of them share orbits with a few of the larger moons. There seems to be an awful lot of debris floating around in the area near Saturn.
And these are what they think are keeping the rings together, is that right?
A couple of those little moons, yes. There is the thought that they're acting sort of as a force to push the ring particles to keep them from spreading out so that the rings stay much as they are.
Good evening. Thanks for phoning Astronomy Toronto.
And how are you, sir?
Fine. How are you tonight?
Not too bad. I'm just going to turn my TV down here, okay?
Okay.
I have a question for Paul, if I may.
Yes.
I'm somewhat of an amateur when it comes down to dealing with the heavens and all that kind of stuff. I was wondering if there's any books that you can recommend to get around with dealing with that. I totally get lost when I look at star charts and things like that.
There are a couple of very general night sky books. Unfortunately, you caught me with that one because I can't remember titles very well. However, one of them is a book simply called The Constellations.
Constellation?
Yes, The Constellations.
Okay.
And basically what it is a look at the ones that you can see in the northern part of the sky, and it shows them to you both in terms of the whole sky, but also individually, and gives you a little bit of mythology background as well. And it's fairly easy, I think, to use in that it shows you a lot of the brighter stars and the way things are outlined. I think you can probably find that. There are a couple of science bookstores in Toronto, and one of them, Science Den or Science City, should be able to help you with that.
I see. Now, another question I'd like to ask you is, how would you go about defining a nebula?
Nebula is simply a large cloud of interstellar gas and dust.
Is that beyond our solar system?
Yes, that is within our galaxy, and the closest one is many thousands of light years away. So, yes, it's far beyond anything that we can send our instruments to.
Is that right, eh?
Yeah.
Okay, thank you very much.
Okay.
I'll look into that. One other question. I got a book called, I think it's called Star Spotters or something like that. When you look at a solar map or a celestial map,
Mm-hmm.
somebody gave me the idea that you're actually looking at a point, and you got to imagine that it's revolving like on a top. Is that the idea when you're looking at that?
You must be talking about a planisphere?
Yes.
Yes. The reason that it revolves is because it tries to show you the sky from any night of the year from a given latitude. So the idea is to note which time you want to go outside and line that up against the day and the month that you're observing, and what you'll see in the clear area by way of stars is what should be visible in the night sky at that time.
Super stuff. Thank you very much, Mr.
Okay,
Stevens.
great.
Okay, thank you.
Bye-bye now.
Bye. Good evening. Thanks for phoning Astronomy Toronto.
Yes, I have a question I would like to ask the gentleman to your left. I'm sorry, to your right.
Yes.
On the space shuttle that is going to be launched tomorrow. And I look at your slides and I'm fascinated by it. And I was curious to what extent, if you do know, the actual men who man the spacecraft that's going up tomorrow will be doing research on planets as opposed to more practical things like defense, defense for the United States, putting satellites up in the air. I wonder if you know anything about that.
Well, first of all, I don't believe it's going up tomorrow.
No, it's
April 4th.
Monday, April 4th.
Monday, April 4th.
Sorry.
And there's almost nothing on any of the upcoming missions, with one exception, that will deal with planets. And that one exception is several years down the road. It is the Space Telescope. When that goes up in '85, what they will be able to do is use that as a giant eye to study some of the different planets. But until then, most of the research that they're doing relates to sort of near-Earth environments.
I think they're really getting started with the space shuttle system right now. This mission coming up, the 6th mission, will be deploying one of 3 satellites that they hope to encircle the Earth, which will allow them to be the space shuttle to talk to the ground all the time. But I don't think the space telescope, what Paul was talking about, will be going up until probably mid-1985, mission 25 or 30 or something like that. So it won't be a lot of planetary study until they get the space telescope up, for sure.
Yes, and one more question. What is the ultimate goal of your studies? What are you searching for, quote, life on other planets, or just in relation to our Earth and understanding why we're here? I mean, what?
Well, I guess there are a number of goals. One of them is certainly a search for life. One of the reasons for going to Mars was seeing if there was life. And now there's this idea that it's maybe in Europa, there might be life in the oceans. That's one, the question of whether or not the Earth is the only harbor of life. More ideas relate as well to a little bit about looking at the history of the solar system to try and see how we got to where we are now, and then take that and try and see where we may be going. And for those who like the truly practical aspects of it, there are groups who encourage space exploration for things like resource development on the moon, to, if you like, get us into space. And this exploration of our local environment is very critical for that.
Thank you very much.
Thank you. Hello, thanks for phoning Astronomy Toronto.
Hi, how are you tonight?
Oh, not too bad.
I have a couple of questions to ask. First of all, how feasible is it to use any of the moons, I guess the closer ones, for mining purposes, or or let's say setting up experimentations and things? Like, in other words, why isn't industry sponsoring more of the exploration of the solar system?
That's a very good question.
I think the main reason is because at the moment things have just not advanced far enough. They're still really playing with the space shuttle. There's only so many of them, and things such as industry and mining on the moon, even if there were industries on Earth who were willing to plunk down several billions of dollars to get that going, in development time alone, it would probably take at least 10 years.
Okay.
Another point with regard to that is, one, the space shuttle will never go to the moon. It doesn't have enough energy. It's just a low Earth orbiting truck. But if if anyone was going to, say, build a really large space station around the Earth, then it would probably be cheaper to go to the moon, mine the minerals, and bring them up into orbit around the Earth, and create the metals and build the structure there, because it certainly takes a lot less energy to pull rocks off the moon than it does off the Earth, just because of the different gravities.
Okay, I had one other question.
Yes.
You know how we've sent out unmanned ships to photograph the various planets. Feasibly, how far can a ship go and still send back pictures? Can it go beyond the solar system and still send back pictures? I know it would take a long time to get them and that, but
Okay.
what are the limits?
Well, as far as photography goes, a spacecraft called Voyager 2 is heading out right now towards Uranus and Neptune, and even from Neptune it will be able to beam back pictures. The problem with beyond that is that literally there's nothing to see. So as far as photographs go, once you get past the planets and the moons, the cameras are generally shut down. Now, several spacecraft are out in space beyond the planets, or getting to the point beyond the planets. In fact, the one is Pioneer 10, which on April the 21st will be passing the orbit of Neptune and heading out, the orbit of, or the position where Pluto is right now. And in fact, by June, it will be further out than any of the planets are, right at this very point. And it is still operating. It takes 4.5 hours to get a little piece of information from Pioneer 10 back to the Earth. But it and Pioneer 11 and Voyager 1 are all heading out into interstellar space. They are still alive, and
there's nothing to stop
monitoring.
them.
That's right.
There's nothing to stop them.
As far as astronomers are concerned, they will go forever, literally.
Well, thanks very much.
Okay, thanks. Bye now. Good evening. Thanks for phoning Astronomy Toronto.
Yes, I have a question. A friend of mine and I were having a discussion, and he was stating that all television communications go on into infinity, and in fact, that the Earth is the so-called, as he called it, the noisiest planet in our solar system and also beyond into our galaxy. Is that true? I'm talking about radio waves.
Right.
Right. Yes, what is happening is if you imagine a sphere centered on the Earth, the edge of this expanding sphere happens to be the beginnings, really, of radio broadcasting in the 1930s, followed by television, say, in the 1950s. So the 1930 programs, and I picked that date because at that point they were really finally getting good signal strength. This sphere of programming is expanding out, and that puts it's expanding at the speed of light, so that puts it 50 light years out. And any civilization that has a large enough telescope that is properly tuned could now be listening to our 1930 radio broadcasts, or in a little bit closer, 1950s television serials, and be learning a lot about us. So in radio regions, in some selected parts of the radio regions, we are the brightest thing around.
One other question.
Yes.
In effect, the closest star is how far from us?
Well, I've been caught on this one before. The closest star is actually our sun, which
other than our own sun.
Right, okay. It's a star called Alpha Centauri, basically, which is 4 1/3 light years away.
How far?
4 1/3 light years away.
So they could be getting our telecommunications up to 4 years ago.
Yes, yes. So they would be picking up things from 1977, 78.
So in effect, that civilization would have a pretty good idea of where we are at
Yes,
today.
that's right. If there was somebody there listening, they'd know all about us, good and bad.
That's a big if, though. Mark that.
Thank you.
Okay. Thanks very much. Good evening. Thanks for phoning Astronomy Toronto.
Well,
Hello.
hi.
What can we do for you?
Can you tell me how far the moon is?
Ah, the moon. Well,
Yes, it's about 328,000 kilometers away on average.
which is about 1.5 light seconds when we're talking about 4.5 light years away or so. Any light to travel or communication to the moon is about 1.5 seconds. But if you want to go to the nearest star, you're talking 4.5 years. Good evening. Thanks for phoning Astronomy Toronto.
Hi, I'd like to know if the the moon revolving around Pluto, would it be considered a twin planet?
Yeah, maybe. It's because the size is really so large compared to Pluto. That is the suspicion that you could almost nickname it a twin planet, yes.
Oh, okay. Thanks.
Okay, thank you.
Okay, bye-bye.
Well, we have a few slides of Saturn's rings, and we were talking about this before, and I put to Paul that, well, maybe all of Saturn's rings should be considered to be moons of Saturn.
Almost, yes. The slide, the first slide that we have of Saturn in general just shows the massive rings going around the planet. And technically, I suppose you could say that each little particle in the ring is a moon. And in fact, that question was raised down when the studies of Saturn were being made. And each one of those little ringlets that you can see is made up of many, many particles. And after a little bit of haggling, what the decision was regarding a moon or a ring particle was that if the scientists studying these photos could make out a solid image of a particle and track it long enough to get an orbit, that is considered a moon. Anything else is a ring particle. So everything you see there in the rings of Saturn are particles and not considered moons.
Have they decided through estimates and photographs what the mass would be if you took all the ring particles and put it together? How big, say, a potential moon would be,
yes,
or what
yes,
could have
actually,
been?
if you lump all of the rings together, you can get a moon of about 200 kilometers in diameter, made mainly of ice and a little bit of rock down at the core.
Good evening. Thanks for phoning.
Hi, how are you?
Oh, pretty good. What can we do for you?
I was just wondering, I have this book, and it says in here, the Andromeda Galaxy is 2 million light years from the Earth, right?
Right.
Okay, now it says here, the Earth on departure it would take astronauts 28 years to get there. That's traveling at the speed of light. And on return, 28 years. And what really puzzles me is it says the Earth would age 4 million years. Could you answer?
Okay. What that is obviously diving into is the theory of relativity put out by Albert Einstein. And basically, his idea is that the faster you can travel, if you are an astronaut, the faster you can travel towards an object, time to you will seem to slow down. Whereas back on the Earth, which isn't going anywhere, it continues along. And as I recall, that particular example implies a speed of 0.99999, lots of nines, almost the speed of light. And if you plug that into the equation, what you discover is that you, as an astronaut, because time seems to be slowing down so much for you, you only age about 28 years when you get out to the Andromeda Galaxy, and if you turn right around and come back, you will have aged 56 years. But the Earth, which is still there, going around the sun, continuing around the galaxy, time continues normally. And so, because it's 2 million light years to Andromeda and 2 million light years back, the Earth is therefore 4 million years old. It's a rather strange sounding paradox.
Very puzzling.
But,
Well, thanks very much.
Okay.
Okay, thanks.
Bye.
I'd like to remind you that we are accepting phone calls, 870-9113, and maybe we'll get a few more questions on moons of the solar system. Good evening. Thanks for phoning Astronomy Toronto.
Oh, I thought I was the one after you.
Pardon me?
No, I thought I was the one going in after you. No, that's okay.
What can we do for you?
You seem to be...
Hello? Well, we seem to have a bit of a problem tonight. One, if we could maybe get a picture of the Enceladus back up, the high contrast picture. One question I wanted to ask Paul was, when we're looking at moons near the Earth, near the terrestrial planets, we get mainly rocks. But as we get farther out, we're getting to icy bodies around Jupiter, icy rocky bodies, and then out by Saturn, they're mainly made of ice. Now,
Right.
do they have any idea what would cause that?
It all has to do with the suspected thought of the chemistry back in the formation, the times of formation of the solar system. And the idea is that the object closest to the sun, a lot of the gases would be blown away by the force of what's called the solar wind when the sun begins to shine. But further out, Jupiter and Saturn, a lot of the gases, the lighter gases, will hang around, including hydrogen, which can combine into oxygen to form water. And the thought is that out there, because of this stuff hanging around, it could condense down and form icy bodies, whereas closer in, what happens, the hydrogen goes, and so you don't get watery, rocky worlds.
Good evening. Thanks for phoning Astronomy Toronto.
Yes, I was wondering about the Einstein Observatory. It has been launched, hasn't it?
Yes.
I think it's been up for a while.
Yes, it's been up for a while, and I do believe as well that it's now ceased to function. They've run out of control gas to keep it stabilized.
Did they find anything out about infrared spectrometry as far as other galaxies are concerned?
Basically, it was a survey satellite to scan across the sky and do a lot of sort of wide-angle searches for X-ray objects. And yes, they did find an awful lot of objects up there that they didn't think were emitting in those areas. And the reason for all the surprise is the regions that Einstein was looking in are blocked by the Earth's atmosphere, so we on the Earth can't study them. And so yes, despite the fact that it had a fairly short lifetime, it was an extremely useful little satellite.
I'm glad to hear they got something out of that anyway. Okay, thanks very much.
Okay, thanks very much. I think now there is also another satellite up there called the IRIS, which is actually looking at the infrared as opposed to the X-ray. Is that
Yes,
right?
yes, and once again, infrared we can't get very well at all on the Earth.
Good evening. Thanks for phoning Astronomy Toronto.
Hello, sir. I'm just flipping through the channels, having to spot you there. I think I shall be tuning in on later dates. Interesting show you have.
Thanks very much.
Okay, with regards to the exploration of the moons and of the solar system and solar system's origin, what kinds of evidence have been uncovered that relate back to the origin of the solar system, and how, if any, how do these explorations relate to the origin of the universe, the Big Bang theories?
Well, the Big Bang end of things, I think, is a little hard to get out of just our local region, because most people, or most astronomers, tend to agree that the Big Bang happened 15 billion years ago or so, and our sun only came into existence about 5 billion years ago. So really, in the exploration of our solar system, we're looking for the very beginnings of our little niche in the universe. And on these moons, what astronomers are finding are hints and evidence from the very early times, because since most of them have no air and certainly no running water, their surfaces are the surfaces that were there 4.5 billion years ago. So we can see what the whole solar system might have looked like, including the Earth, some 4 to 4.5 billion years ago. And by counting craters, by dating techniques, we can see a fairly good evidence for a lot of cratering early in the solar system, tapering down to very little, which indirectly is shown on Earth today, because of course we don't have very many craters, which is a good thing. It implies that there's not much cratering activity right now, and this tends to help reinforce some of the ideas about the early solar system.
Thank you very much.
Okay.
Okay, thanks. Good evening. Thanks for phoning.
Oh, thank you. Paul, I'd like to direct a question to you.
Yes.
Why are we putting such an effort to find out if there's life outside our own world? I don't believe there is within our own universe.
Right. Well, basically, it comes down to a question of, I guess, of wanting to know. And on one hand, if there is a lot of life out there, it means that we are not unique, but it also means that we can learn a lot more in a hurry. and by hopefully somehow tapping into these other sources. However, if, as you suggest, there is nothing else out there, then that implies that we are extremely unique, and I think it means that we should be very, very careful with the life that we have on Earth, because it is obviously very precious and very unique.
Well, I agree with you. It is very unique. And we're putting ourselves in a very difficult situation in our own world crisis right now.
Right. Okay, thanks very much. I think another indication of our desire to look out into the universe is the popularity of, say, something like E.T. We have no idea if there is anything out there, and if there is another civilization out there, are they going to look like E.T. or what? We have no idea. But just recently, the first organized search for signals coming into Earth was started up, the search for extraterrestrial intelligence. And this is a big step, because if we're not listening, we're not going to hear them if they happen to be sending out signals to us.
That's right. It is the first truly organized attempt to do this. And of course the counter-argument is, well, if there's nobody out there, of course they won't be signaling, so it's a waste of money, to which the reply is, if we don't listen, we'll never know.
Well, we're certainly talking about the Voyager spacecraft tonight, and we've looked at the flybys of Jupiter and Saturn, but Voyager 2 is still on its way out to other planets. How is the Voyager, Paul? The encounter was with Saturn in 1981, was it?
Yes.
Got a bit damaged. Is it,
yes,
is it still all right?
Voyager 2 is alive, though not necessarily well. The little scan platform on which the cameras sit has two motions, one that goes this way, one that goes this way. This way, it's jammed and will only go part way. It has only a backup radio receiver. It seems to have a little problem with its memory. But stored within its computer brain is a science program to go on at Uranus, so that once it got past, you receive the Voyager flyby at Saturn, and at this point instructions were promptly beamed up to it, which it accepted, so that now even if we lose total contact with the little spacecraft, it will do its science mission at Uranus. And this, in 1986, is a computer simulation of what it should look like, flipping past Uranus and its little ringlets. Then, hopefully, it will take more commands, because it will automatically go on to Neptune, whether we can talk to it or not. And the hope is that in 1989, planet Neptune will be explored. And also, one of the largest moons in the solar system, a moon called Triton, will also be looked at, the flip past of Neptune and then of Triton.
Good evening. Thanks for phoning.
Yeah, how are you?
Pretty good.
I would like to know the spaceship Columbia. How long will they be going up there for?
Well, I think the Columbia is it's getting its overhaul now, but each orbiter is scheduled to make about 100 flights. And
Like April 5th. Is that when they're going up?
Oh, sorry. The next mission is scheduled for April 4th.
Right.
This will be the new orbiter called Challenger, and they'll be up there from Monday through Saturday.
So how long, the Challenger, that's the new spaceship, how many missions have they made, that one?
Challenger, it's going to be its first mission.
And has anybody ever gone to Saturn?
Nope.
Nope.
Just little unmanned spacecraft.
Yeah. Farthest we've ever been is the moon. That's only about 20 guys out there.
Planets there that you know they're there, but they might go there one day, but they're not planning to go there in a few years?
There is a possibility. Obviously the first flight to another planet would be to Mars, I think, since it's the closest. And I think it will take a while to work up to the point where we can send people out to Saturn and beyond, because that's quite a distance away, and we certainly do not have the technology you see in movies like Star Wars yet.
So, like, when you go to the rings, like, when you get by, is there a gas that, would push or break the Columbia?
Oh, no, no. The shuttle will never get that far, ever, I think I can safely say. And any unmanned craft, no, you have to carry your own fuel with you and do all your maneuvers using your own fuel.
Okay, thank you.
Okay, thank you.
Bye. One quick question. We have a few minutes left. Can we help you? Good evening.
Hello.
Hi.
You mentioned about an astronaut traveling at the speed of light
Right.
and going out in space. One of the properties of the theory of relativity is that as matter approaches the speed of light, its mass tends to become infinite.
Right.
So how would that affect an astronaut? Would his mass from his own point of view become infinite, or is it only becoming infinite from some other point of view?
Yeah, it becomes infinite basically from another point of view. The astronaut would not notice any difference, even though we on the Earth would think he's becoming pretty heavy.
So,
as Einstein would say, it's all relative.
how would he view? Oh, I see. So his view of his ship and his immediate environment would
It
remain
would
the
look
same.
perfectly normal.
So how does the rest of the universe appear to him if he's becoming so much more massive to the universe?
Well, that one I don't think I can really answer in a few seconds. I think that would take a long while to think through.
Ask us next month. We're going to have an astronomer on. Okay?
Okay, thanks a lot.
Thanks a lot. Okay, so Paul, again, we've got Voyagers out there, and we've got Galileo. In the last 30 seconds, what's Galileo going to be doing?
Basically, Galileo will go to Jupiter, flip around Jupiter, go on sort of a looping mission between Jupiter and its moons. Before it gets to Jupiter, it'll split apart, send an atmosphere probe down into the gases of Jupiter, and the rest of it will be lots of photographs of Jupiter and the moons.
And this is when?
Well, it changes all the time. I think the last thing I read was launch again in '87 to get to Jupiter in '88.
Super. Again, Paul, thanks very much for coming and
My pleasure.
showing us
Thank
all
you.
these great shots and telling us about the solar system. It's
Okay.
been a pleasure. And again, this has been Astronomy Toronto. We're seen the last Wednesday of every month here on Rogers Cable 10. And my name is Randy Attwood, president of the Toronto Centre of the Royal Astronomical Society of Canada. If you want more information, we'll be flipping up an address that you can write to find more about the Royal Astronomical Society of Canada, care of the McLaughlin Planetarium here in Toronto. So our next month, stars, black holes, all those really wild things. So we hope you can join us then. Bye for now.